All right, some practice problems that we haven't really we talked about indirectly, but this is a more direct look at some of the problems from that you'll have to work on in class with vectors. And the way you do these, it's all about adding vectors. And so the best thing to do is to draw the vectors, and then you're going to put one on top of the other. You're adding their x and y components. So it's just a whole lot of repeating the same. It's just interpreting the questions that's challenging. So for instance, for this first one, number 49, when you deal with forces, the length of the vector you label by its force. So 50 pounds and 75 pounds. 75 pounds would be longer, 3/4 longer, or 50% longer than the 50-pound one. So you put it up at a particular angle, you graph them, put one on the end of the other, and you're home free. Sounds easy, but you always know there's more complication to it. Now, when it says at an angle of 45 degrees, that does mean a direction angle. So 45 degrees is straight out at a 45-degree angle. Nothing fancy, no confusion to go with that one. So here it goes, 45 degrees, we'll call 50 this length. Okay, so that's 50, and you can label it as such. That's your 50-pound force. And then there's another that's 75 pounds, and that's at an angle of -30. So if I go to -30, and again, I'm going to roughly approximate these, get my thing to work here. I'll put this one in as pink. That's, roughly this direction, and it's 75, so it's longer. Ooh, I got that straight angle thing going. That's cool. So 75. To gather the result of those, you have to take that particular vector we just had, that's 75, and we have to put it at the tip of this one. So you actually slide it up there and write it again at the tip of the other vector. The resultant vector, the sum of the two, is from the origin to the end of the combined vectors. So here's the one I'm looking for, that green vector. And the way we can add them together real fast is using that kind of shortcut formula. We had the purple one, which was the first force, had a magnitude of 50 and a direction angle of 45, so cosine 45. And then the y component would be 50 sine 45. Ta-da! And you're going to add to our pink vector, which is 75 cosine of -30. And you get now -30 is what we're going to find out is it's easier. Your calculations are much simpler if you always go from 0 and you always go the same direction. So rather than -30, I'm going to put in there 330 degrees, which is the same thing as -30, but it's always from 0. It maintains all the right directions and quantities that go with that particular recording. Sine of 330. Got it. Add those two together. Calculator can be in hand. This is an exact one, so each of those values you can get exactly. And so be prepared not only to do it in the decimal form, but to do it in the exact form. So for instance, if I write it off to the side in numerical form, 50 cosine of 45 would be like 50 times the square root of 2 over 2. And same thing as, the other one would be 50 cosine 2 over 50 square root of 2 over 2 as well, because that's the cosine of 45 and the sine of 45. Okay, so those are the exact values you need to be able to come up with, as well as the decimal values that go. So be ready to do both. But that sets you up to add them together to get the resultant vector is the sum of those in exact and or decimal form. So just add them up, get your x component, add them up, get your y component, and you are done. Okay. Down below, it can go for any of these vectors. Now, the only thing to watch out for is when it gives you an angle like you see here that's like 15 degrees down. That green's a terrible color on a green background. Let me try that again. Instead of 15 degrees down, the direction of the first one for the girls vector, for instance, would be 23 cos 18, 23 sine 18, just like you'd think it would be. All right, got it. And then, but for the boy, you want to make sure you get his direction as 27 cosine, and the angle from 0 all the way around is going to be 345 degrees, because it's, down 15 degrees is the same as going around counterclockwise 345 degrees. So just be careful. So there's 27 sine 345. Got the boys stuff. If you want to know the resultant vector, like where it goes and how fast, It is the sum of those two. And physically, you take one on top of the tip of the other, but I think you're getting the idea now that if you want to know what the resultant combined vectors is, we just add their components and you get that resultant vector. So you're going to add these two together and you're going to get a nice resultant vector, just like we did in the first problem. So a lot of the same thing over and over again. The biggest thing is you want to make sure your angle is the direction angle from 0 anytime you take it on. Some of these have directions, like headings that are a little bit different. So when you're drawing the vectors, like number 4 says airplane at a fixed altitude with a heading of south 70 west. These are funny, but this is from, yeah, you're hearing instructions in the background, but multitasking here.
That's all he tells me about this class.
Yeah, from and toward. It has from the south toward the west. Yeah. So here's the south, here's the west. If you go 70 degrees, it's from the south, you're going to go toward the west 70 degrees, and you make your vector that is labeled as 400 miles per hour inside there. Okay, so that's your first one. And a wind blowing northeast at 40 miles per hour. Northeast at 40 miles per hour. Northeast without any other indicator, it means directly at 45 degrees, and that will be length 40. Now, physically, if you want to know what effect they have, you put one on the tip of the other to see it physically. But the idea of combining wind and those, you're going to add them together. So you're going to do 400 cosine the direction angle of your particular airplane. And remember, your direction angle has to be from 0. So you got to figure out how many degrees that is. And if you remember, this was 70 here. So you're dealing with 20 degrees here, 90 degrees in here. You got to do a little mathematics. This is 45 right here, and this is 45 here, or just do 90. But you get 180 plus 20 is going to give you the direction angle. So that's a total degree of 200 degrees. Okay, so and that's just your x component, y component, the same thing, 400 sine 200. Same stuff. Okay, that's just the plane. I'll let you guys find the wind. The idea is add them together to get your resultant vector. But the question says find the actual ground speed, which means I want you to get the magnitude of the combined vectors. So ground speed means when you're done, it's the magnitude, the Pythagorean theorem of the values in your resultant vector. So magnitude of resultant vector. You got to do Pythagorean theorem on the end result value. So if this is A and that's B for your resultant vector after you added them together, you're going to go square root of A squared plus B squared. Okay, to get the speed. The ground speed is how fast, how long the arrow of the resultant vector is. Down at the bottom, you have many more of kind of the same thing. Same issue in this particular picture. As wonderful as that picture is, when you do these vectors, the angle you need is the from 0 direction angle. So for each of these vectors, you need to find that angle as a direction angle. So for the first one, that's 30. For the last one there, you're going to have to find that angle as well. Now, the angle between is a question that comes up. If you guys graph two vectors and you want to find the angle between two vectors, I'm going to let you guys go and do the mathematics, but you just need to find the corner angles for each vector and add them together for the angle between. So do a little problem solving. That's part of your challenge today, is work together and resolve this. It's just right triangle trigonometry. Everything you can do to come up with it, problem solving wise, make some triangles, you're good to go. See y'all soon.